Europe has a vast collection of coastlines and rivers, over 100,000 kilometres of coastal zones and an estimated 1.3 million kilometres of rivers, influencing the water that runs to our seas and ocean. Coastal zones are particularly vulnerable to climate change, extreme weather events, sea level risings, and the heavy footprint of human activity. The European Union's Copernicus Marine Service delivers monitoring and forecasting systems at global and regional scales. With increasing concerns over climate change and anthropogenic effects, and growing needs from blue economy and member state stakeholders, Copernicus Marine needs to expand and improve its environment monitoring and forecasting services to ensure the delivery of accurate data and forecasts adequate to the complex coastal zone.
The FOCCUS project gives the opportunity and the perfect platform to seamlessly integrate the member states' coastal services together with the Copernicus services. We will use the novel high-resolution satellite and in situ observation data together with the novel approaches and information coming from the land.
European projects such as FOCCUS are very much needed for the evolution of the Copernicus Marine Service to remain at the state of the art, but also to better answer user needs and policy needs.
We are bringing together the key communities that can better predict the coast.
We're taking this integrated approach to observing and modeling the ocean. Since making ocean observations is so costly, both remote sensing and in situ, we're now looking at optimizing the projection chains and put that into the coastal ocean modeling systems so that we can get more sustainable management of the coastal zones.
We have to do better to meet the actual needs of coastal communities because they need better resolutions.
More than 50% of the search and rescue accidents are occurring within 3 kilometers of the coast in several Western Mediterranean countries. By having these high-resolution surface currents products will help for sure to the emergency responders.
One of the potential outcomes of the project will be to achieve information that is coming from the remote sensing that we can implement in the numerical models, and then we can improve the forecast.
Coastal processes are highly impacted by river runoff. For instance, the volume discharge impacts dynamics of the coastal areas, and sediment and nutrients transport carried out by the rivers impact the water quality on the coast. So we need more river data that can come from in situ or from hydrological models.
We have a pan-European model where we simulate freshwater inflows and the nutrient inflow sediment to the coastal areas. And within FOCCUS, we are updating the nutrient sources of pollution there so that we can improve our model. We are using machine learning approaches where the outputs are going to be adjusted specifically for the coastal applications.
The coastal applications in FOCCUS has a pivotal role to harmonize and integrate all the feeding components: observation, the land-ocean continuum, coastal marine services. We want to ensure a sustainable development of the blue economy.
One exciting aspect of the FOCCUS project is the co-production between Copernicus Marine and member state coastal services. FOCCUS will contribute heavily on building the coastal extension of the Copernicus Marine Service. And this is much needed given the huge importance of coastal zones for our economy, our society, and our environment.